this thing here last time. Guys, I know this time you have your calculators with your hand. This is an online class right now, but if you take further mathematics, you need to know how to make this unit circle, which is very, very important. So make sure you know how to draw this unit circle. Unit circle means basically we are drawing a circle whose radius is 1. So it's gonna cross this point 1 0 and we'll draw a circle whose radius is 1. And what we figured out is we did this point was it's gonna cross at 0 1, here it's gonna cross at negative 1 0, here it's gonna cross at 0 negative 1. These are the points this circle crosses at. And then this was known as, so this we start with 0, then we got 90 degrees, then we got 180 degrees, then 270 degrees, then 360 degrees. We kept on adding 90, 90, 90, and you can keep on going like that. And also you can convert into radians. It is 0, this was pi by 2, this was pi, and this was 3 pi by 2. That's what we did. Also what we did is we found the value of pi by 4, which is 45 degrees. It was square root 2 over 2, square root 2 over 2. And the other few things which we learned last time was, we learned that sine x is equal to the y coordinate. That's what we learned. Cosine was the x coordinate. I would say theta rather than saying x here. So, tangent theta was basically y divided by x. Secant was opposite of cosecant. Cosecant theta was, if this was y, this became 1 over y. You just flip. It was y over 1, it becomes 1 over y. Secant theta was basically 1 over x. And similarly, cotangent theta is x over. Remember, this is for unit circle. I'm not talking about anything else. Unit circle. That means in this radius is given to be 1. These are the few things which we learned last time in the previous lecture. Okay. Also today what we're going to learn is, first thing we're going to learn is how to find the value of when my theta is 30 degrees, which is pi over 6, or my theta is 60 degrees when it is pi over 3. We're gonna find this thing. Okay, since we're gonna find this thing, I'm telling you again, I'm repeating this thing is, since it's online class, you will already have this thing in front of you in your exam. But if you take further mathematics, you should know how to draw this yourself. These values which we're gonna make on the final, this table, you should know all of them. Okay, there you won't be allowed to use your calculators. Okay, in this case, how you find it is, so you will be given a triangle. I say I'm given this triangle. Okay, I say this is my, I call this as my A, I call this as my B, and I'm saying my hypotenuse is 1. My hypotenuse is 1. Okay, if I say this thing is 30 degrees, I say this thing is 30 degrees. This is 90 degrees. When you make angle like this is 90 degrees. That means 90 degrees, this square. Can anyone tell me what will be the measurement of this angle?
180 degrees.
If this will be 180?
60.
Why 60?
60.
Because all triangles add up to 180.
Yes, exactly. Because the sum of all of them is 180. So this is supposed to be 60. How do you do it is add all of them. 90 plus 30 is 120 and you subtract from 180. So that's how you got 60. I know this is gonna be 60. So since it's a right angle triangle, I definitely know a square plus b square is equal to 1. I'm using my, I'm just showing you the derivation. You don't have to remember this, but you should know the values. So you got a square plus b square is equal to 1 by Pythagoras theorem. So you have side square is equal to the hypotenuse square. You got this thing. What I'm gonna do is I'm gonna make the same triangle on the other side with my b as the same. So this becomes a, this again is 1, and this is again my 60 degrees, this is 30 degrees on the same side. So now this is 60, this is 60, and this is 60. Anyone who knows anything about when your angles are the same, equilateral triangle, what happens?
All sides are the same.
All sides measurements are the same. If your angles are same inside, like this is 60, this is 60, and this is 60, so all sides will be same. This is 1, this is 1, this whole thing will also be 1. So what you get is 2a is equal to 1. You get this thing. Once you get this thing, you can find the value of a, which is 1 by 2. And you know the formula here. We found a formula here. We're going to plug in here 1 by 2. You get 1 by 2 square plus b square is equal to 1. Solve. You get 1 by 4 plus b square is equal to 1. When you solve, you get b square is equal to 1 minus 1 by 4. How do you make a common denominator here? Multiply by 4, multiply by 4.
Wait, why does 2a equal 1 again?
Okay, see, because it's an equilateral triangle. This is also 60, right? 30 plus 30, 60. This is also 60 and this is also 60. Since it's an equilateral triangle, there's a property that all sides are the same measurement. I know this was 1, this was 1, so this whole thing is also 1.
Oh, okay.
Yeah. Perfect.
Okay.
So you got b square as 3 by 4, but I need the value of b. So I'm going to take square root on both sides. I get b as square root of 3 over 2. So I got my b as square root of 3 over 2.
What's that say right there? B squared equals... Yeah.
It is 1 minus 1 over 4.
1 minus 1 over 4.
And then in the next step, what I'm trying to do is I'm trying to make the same base. I'm multiplying the numerator and denominator by 4. You got your b. Now I need to find my a. I need to find my a value. Again, I know the property here. A square plus b square is equal to 1. Oh, a I already know here. A I know, b I know. I already know. I don't have to find it. I don't have to find it. Now, let's see here. So if I say here, so this is my unit circle. I'm going to draw a unit circle again. This is my unit circle again. Let's talk about 60 degree only. So far, I'm just going to talk about 60 degrees. So I say this angle here is 60 degree. And I say, I draw a line here like this. So just to figure out what this point is. Note we drew here right now. The angle opposite to 60 degree here is, so this 60 degree, right? So this point B. So we found the B here, which is my y coordinate. It is root 3 over 2. And x coordinate here. How much is my x is, we found is 1 over 2. Are you getting how I drew this or no? Anyone who wants me to explain how I drew this thing? How I got this point here?
They're just basically trying to basically just get you use a unit circle to find the 6 degrees. and then you try to make like an imaginary like right triangle for that.
Yeah, exactly, yes. The thing is,
And
I'm
then
trying
depending on the where it is, it would be like the hypotenuse will be narrow or it will be taller, right?
narrow or tall. Yes, hypotenuse, it depends, yes. But the thing is, why I'm drawing this thing, you don't have to draw this 90-degree all the time. The reason I'm just drawing this here right now is to figure out this point. Note, this line tells me the x coordinate. See, it will tell me how much I'm going towards my x, this point, how much it is going towards the x. And this tells me how much I'm going towards the y. So it just tells me x and y coordinates. That's the only reason I'm using. I'm again repeating, you don't have to memorize this whole step here. You just have to memorize when it's 60 degrees, when they're asking you 60 degrees, the point here is 1 by 2 comma square root of 3 over 2. That's your main thing. Any questions, anyone? Let's see 30 degrees now. So if I have to draw 30 degrees, so suppose again I make a circle here. Make a circle here, and I say now I need 30 degrees here. $30 degrees. So if you see here, what we did is 30 degrees here. I know my hypotenuse is always 1. But the base, now this is my base here. This is my base, and here B was your base. For 30, if you rotate here, you have to rotate your triangle and it will become like this. It becomes like this now. And now B becomes your base. In this case, my x will become as square root of 3 over 2 and my y will be 1 over 2. It flips in case of 30. It flips in case of 30. That's what you need to remember here. These are the important values you need to remember for 60 and 30. I again repeat, if you take higher mathematics, you need to memorize all this. You need to memorize the unit circle, which is very important. Okay. So next thing it says, find the exact values of, okay. It says, find.
Wait, can you explain why it flips?
Explain.
For 30?
For 30, why it is like this?
Mm-hmm.
Okay, so remember I drew a triangle like this. Okay, and I call this as 90, we call this as 30, and we call this as 60, right?
Okay.
This was 1 we found. This value we found as 1 by 2, which was a, and this we found as square root of 3 over 2.
Oh, okay.
So if you try to put that thing here, this triangle here, you will get these values. So this will give me my x coordinate. And what was the base? 30 and 190. What was the measurement between 30 and 90? So this is my 90 here, right? So measurement between 30 and 90 is square root of 3 over 2, right?
Yeah.
So my x becomes square root of 3 over 2.
And then 1/2.
And 60 and 90 between was 1.5, so my y becomes 1.5.
Okay.
Yeah.
Mm-hmm.
Anyone else who did not understand this thing here? I can explain again, guys, it's okay if you did not understand. Okay, so then it says find exact values of trigonometric functions with of, or you can say of pi by 3 is equal to 60 degrees. So pi by 3 or 60, it means the same. This is in radians, this is in degrees. So can I have here Carly?
Yes.
What is sine 60?
Pi by 3. Radical 3 over 2.
Did you use calculator?
Oh, no, I was looking at the unit circle.
Okay, so unit circle, how did you find it was square root of 3 over 2?
Because the coordinate is 1/2, and radical 3
And the
over
second
2.
one is my sine, right?
Yeah.
What about my cosine?
1/2.
The first one is that one. Okay, what about tangent?
Tan would be y over x, so
Square root of 3 over
radical
2
3 over 2.
divided by 1 over 2.
Oh, okay.
And when you solve, what do you do? How do you divide radicals?
You change the division sign to a multiplication
And then
flip the 1/2.
exactly it becomes 2 over 1. Then cancel whatever you can. You're left with square root of 3 over 1, which is just square root of 3. Okay. What about cosecant?
Would cosecant be 2 radical 3 over 3?
2 radical 3 over 3. Perfect. Yes. You flip it and then she rationalized. Yes. What about secant?
Secant, would it be just 2?
Yes. 2 over 1, which is just 2. What about tangent? Or cotangent?
That would be x over y. So
Or you can flip tangent. Flip the tangent.
oh, okay.
So what does it become?
That would be 1 over radical 3, but then it would be radical 3 over 3.
Yeah, which is radical 3 over 3. Perfect, Carly. Really good. If you have any questions with this, guys, ask me right now.
Yeah, how did you get the
Cosecant.
secant 60?
Yeah, cosecant 60, how she did it is you just flip the sine one. So when you flip it, you get 2 over square root of 3. But you cannot leave square root in the denominator. So what you have to do is rationalize. How do you rationalize this? Whatever is the square root, you multiply and divide with that same thing. And then you solve. You get 2 square root of 3 and the denominator, you have 2 square roots. Square root cancel and you are left with just 3. Did you get it, Anwandai?
Yeah.
Okay.
Thank you.
Similarly, she did with cotangent also here. She rationalized.
Can you hear me?
Yeah, I can hear you, Angel.
Oh, so in order to find the secants and the cosecant of whatever degree it is,
Yeah.
we have to first find the coordinates.
Yes, you always
And then
have to find the coordinates. Yes.
Okay, and then we use those coordinates to like secant's always y. I mean, sine is always y, so we just get whatever y coordinate it was.
Yes.
Okay.
Yeah, cosine is always x and tangent is y over x. Yeah. Any other questions, anyone? Similarly, find for 30. So we just found for 60. I want you to find for 30 now. So it says find all values for 30. 30 is pi over 6. Remember these are the very common ones. 0, 30, 60, 45 and 90. These are the 5 ones you need to remember the radians by heart. Don't convert. You should know what we are talking about. Pi by 6 is 30. So let's see what coordinate we got for this thing was root 3 over 2 and 1 over 2. This is the coordinate we got. Okay, Jelena. Jelena here? No? Jelena is not here. Axel?
Oh wait, she's here. She just came to chat.
She's here.
Okay. What about Axel? Is he here?
Yes.
Okay, Axel. What's the sign? Sign 30.
Wait, give me a second. Sine 30 is 1/2
How did you say that?
because it's the opposite.
What do you mean the opposite?
Sine is using the opposite of the triangle.
So this is your coordinate. This is your coordinate. From this thing you have to
Yeah.
tell me what's my sine value.
Y.
y1, which is 1 by 2. What about cosine?
Square root of 3 over 2.
Okay. What about my tangent? Tangent, I will got 30 degrees. What's my tangent?
One half over square root of 3 over 2.
Over, so I'll write, since there's too many division signs, I'm going to write it like this. And how do I divide these?
You subtract one negative because it's the same base, or what?
No, how do you divide these? So what happens, I change this into multiplication. When you change into multiplication, what do?
Oh, you flip around the numerator and the
Yeah, the second one.
denominator.
So when I flip these cancel, I'm left with 1 over square root of 3. But I cannot leave square root in the denominator. What do I do after this?
You multiply by 3.
Multiply by
3?
square root of 3.
Yeah.
The same thing with the square root. So in the numerator, I get square root of 3. But in this case, 2 square roots, they cancel. I'm left with just 3. Okay, let's see here. What about cosecant? Axel.
Oh, my bad.
You just flip the sign.
Cosecant is cosine, right? Like the opposite of cosine?
Yeah,
Or-
cosine, yes.
What do you mean you flip the sign again?
Just flip, so whatever you got for sine, cosine is opposite of sine. So you just flip it. So sine you got as 1 over 2, right? Cosine will become
Yes.
2 over 1, which is just 2.
Alright. So cosecant would be 2 over
One.
square root of 3?
Yes. So what will be secant? Secant is opposite of cosine. So it becomes
2 over the square root of 3, but since that cannot happen, it is the cosine of the square root of 3 over 3.
yeah, 2 square root of 3 over 3. What about cotangent? Note you got cotangent 30
Square
as
root-
1 over square root of 3, right? Initially.
Yes.
So if I flip, what do you get?
Can you repeat that again?
So tangent 30 you got as 1 over square root of 3 when you solved.
Yes.
You flip that, what do you get?
The square root of 3?
Yeah, over 1, which is, so that's your cotangent. If you know these values, you can find all the values. So far what we did is, so far if I make a circle here,
I thought cotangent was 2 root 3 over 2.
yeah, cotangent, you're talking about here, cosine or secant, what are you talking, cotangent, right?
Yeah, cotangent.
Okay.
Cotangent 30 degrees.
Okay.
I thought that was.
The thing is, what I did is I used this thing. You can use this thing also. If you flip, what does it become? 3 over square root of 3, right?
Yeah.
Then you rationalize again, because you cannot have in the denominator square root. You are left with 3 square root 3 over 3. 3 cancels, you are left with square root of 3. Did you get it?
Oh, well, I did it. I was root 3 over 2 divided by 1 over 2, and then you would multiply
Where did you get 1 over 2 at?
from our y value.
Okay, you are doing that way. Okay. So you're saying it will be 3 square root of 3 over 2 divided by 1 over 2, right? Cotangent is x divided by y.
Yeah.
So you got this thing. Then you change division into multiplication, the next one flips.
Mm-hmm.
Then 2 and 2 gets cancelled, you are left with square root of 3.
Oh, okay. So the 2 and 2 get okay. That makes
Cancelled,
sense.
yes. So next thing I'm going to do is I'm just going to combine right now what we did so far. So this was my unit circle here. Okay, this point, see the way I am memorize, I memorize this, you have to also memorize the same way. So this is basically 1 0. Remember this point, this is radius 1, so it cuts at 1 0. This here it cuts at 0 1. Here it cuts at -1 0. Here it cuts at 0 -1. This we know. Okay, then here with what we need is now is 30 degrees. Then we need 45 degrees, and then we need here is 60 degrees. And we know here is, so this is basically, you can say 60, this is 45, and this is 30 degrees. Okay, and we know this is 90 degrees, this we know is 180 degrees, this we know is 270, and this is 360, and this is also 0. If we have to convert into normal thing, this was 2 pi, this was pi over 6, this is pi over 4, this is pi over 3. I'm converting into radians, this is pi over 2, this is pi, this is 3 pi over 2. Also what we learned is for pi by 3 it is square root of 3 over 2 and 1 over 2, and pi by 6 opposite, 1 over 2 square root of 3 over 2. And then pi by 4 is square root of 2 over 2 square root of 2 over 2.
I mean, I got a question.
Yeah.
If you're gonna be doing it beyond the 90 degrees, it would like turn all of those the 3 over 2 by 1 over 2. It would turn itself into its negative versions?
Yes,
depending
exactly.
on where it is?
Yes, exactly. That's the next thing we are doing after this. This is the next thing we will be doing.
Oh, so we're just going to be using these three degrees. We
Yes.
start with these 3 degrees, and then we can find the rest.
Everything else, yes.
Okay.
You will see that's what we're gonna do. That's about trigonometry is. So we basically 1, 2, 3, 4, 5. These 5 values, and you can find everything else. So let's see here. Okay. After this, what we're gonna do is this we found values in this coordinate here. So this is first one here. For first part we got this. Similarly, you will have values here in the second one, third one, and the fourth one. How do we find it is, exact multiples of, so now this is known as exact multiples of 45 degrees. Exact multiples of 45 degrees. Let me see, it's it. Oh, Daniel, can you hear me? Karen? Oh,
Yeah, we can hear you.
oh, it's Jill, okay. I did not read the first one. Okay. Exact multiples of 45. So how do you do that is, how do you find the exact multiples of 45 is? So you are given, what I want you to draw is, you are given this circle. Okay. You're given this circle. I found out this 45 here, 45 degree here. It gives me root 2 over 2 and root 2 over 2. I found this thing here. Okay, and I know when I'm drawing this next part, I just want to know is this thing is 0 and 2 pi. This thing is pi. I'm converting into radians, or if you want, you can do into degrees also. 360, and you know how to convert into degrees to radians and radians to degrees. There will be something, the same angle here, which will give me square root of 2 over 2, square root of 2 over 2. How do you find it is, from 180 subtract the same angle. From 180 subtract the same angle, 45. Since we're talking about 45, let's subtract from 180 45. Tell me, what do you get? You get 135. So you will have an angle here. This whole angle will be 135, and you know what the coordinates of this one will be? It will be again square root of 2 over 2 square root of 2 over 2. But note, in this case what happens? This side my x is negative and y is positive. So my y will remain positive, only my x will become negative. That's how you find your angle. And from 180 subtract whatever you want. I want it for 45. I subtracted 45, I got 135. So this 135 angle will give me negative square root of 2 over 2 and square root of 2 over 2. Now I need to find in this coordinate. In this coordinate, you add in for 180 whatever you want. You add. So I add here. What do you get? 225. So here will be 225, and that will give me, note here, in this part here, my x and my y, this point here, my x and y both will be negative. So square root of 2 over 2, it will be negative, both of them. To find this angle, I subtract from 180. To find this angle, I add in 180. Now I need to find this angle here. This one, in this coordinate also. Now how to find this thing is from 360. From this 360 line, I will subtract 45. See what you get. 315. So at 315 degrees, note in this coordinate here, this point here, my x is positive, but my y is negative. So my x will remain as it is, my y will become negative. Note for 45, I found everywhere.
And for 30 degrees, it would be what we did before, right? It would be the root 3 over 2 to 1 over 2.
Yes.
And then we'll do the same thing for all those sides, right?
Exactly, for all of them, yes. And you will find the angles for all of them and change the signs.
So going forth, so our 40 degrees, that later on, like, and for any theta, whatever theta would be, we're just getting to find the first quadrant, or what's that, the one on the left, the second quadrant?
So this is known as, so let me show you quadrants, okay? This is known as, so this is your first quadrant, this is always known as second quadrant, third quadrant, and this is known as your fourth quadrant.
Okay, so 180 minus 40, that's to find the second quadrant, and then
Yes.
180 plus 45, that's to find the third.
Yes.
And then 360 minus 45 is the fourth.
Yes.
Okay. Oh yeah, that's honestly, that's way
Yes,
better.
exactly.
I like that.
Yes. That's how you find it. Perfect. So if we have to talk about 30 now, let's talk about 30 so that you guys know about 30. So this is your, I say here, this is your triangle here, this is your 30 degrees, and 30 degrees what we found was 1 over 2 and square root of 3 over 2. I say, what's the angle here? For this angle, what you have to do is you have to subtract from 180 30. You got as 150. So for 150 here, for 150, what will be the angle here? Note, it will be the same thing, 1 over 2 square root of 3 over 2. But at this point here, my x is negative, but my y is positive. So my x will become negative. Similarly here, find this one here. How do you do? In 180, you add 30. You get 210. So this is my 210 here. Again, in 210, so again I will have the same thing. But what happens in this case? My both x and y are negative. So I'm going to put negative in front of both of them. This, how do you find it? From 360 subtract. You got 330 degrees. So this is going to be 330. Again, it will be the same thing. But in this case, only my y is negative, but my x is positive. So my y becomes negative.
Quick question.
Yeah.
On the homework, it would give us degrees that were like really, really high. Like, for example, 1890, which on the unit circle, that's actually 315, degree of 315. How do we get it down to like
So the
find?
thing is, that thing I haven't taught you. After this, we'll be learning that today.
Oh, okay.
Yeah.
Okay.
Yeah. So far, whatever homework will be assigned to you, it will be related to these values, what we are doing today. So
Oh,
it will
okay,
give you
okay.
150, 210, 330. You should know these values. Yeah. And make sure I'm not converting into radians. You should also know the values of these in radians. Whenever you make the final, the table, make sure you put in radians, plus you also put in degrees. I want everyone to find for 60 degree also. I found for 30 degree. Similarly, you can find for 60 degrees. Okay. Can I have Axel already answered? Alejandro? Alejandro is not there. Jose?
Yeah.
Okay, let's make this table. And can you tell me for 60 degrees? Okay, this is my 60 here. And my coordinate here is 1 over 2. Yeah, square root 3 over 2 and...
You just want the points, right?
Yes. So, what will be my next angle here in this coordinate here? Second coordinate.
Isn't it like 120?
Yeah, 120. And what will be my measurements of here, angles?
You'll have a negative x. So it's the same thing, just a negative x. And
Okay. What about
for
this
the
here?
bottom, what was that?
For this third quadrant, what's my angle?
You'll have a negative x and y.
Yes, negative x and y, but what will be my angle?
It'd be 225?
Why 240?
Or wait, no. It's 180 plus 60, right?
Yes.
It's 240.
So this is gonna give me 240 degrees. Okay, what about this here?
Mm-hmm.
300.
So you're saying
But that is going to have a just negative y.
negative y. Perfect. Yes.
So I guess there's just a pattern to the x's and y's on each quadrant, right?
Yes. Yes. Exactly.
Okay.
So this
I
is
think
how
the
you. Yeah.
coordinates are backwards.
Yes. Oh, coordinates are
I think
backwards.
Jelena said that y is square root 3
For 60.
over 2. Yeah, for 60
Yeah,
degrees.
you're the points
They're
are
switched.
backwards.
0, 0, 1 by 0, 1 by 2, 1 by 2, 2, 3 by 2.
Your
Yes,
x's
it
and y's
is.
are
It is
backwards.
opposite. Yes, you're correct. So basically, I drew previous one as 60 and this as 90 for coordinates. So this is 0, 1 by 2, 0, 1 by 2, root 3 by 2. Yes, it's gonna be this thing. You're correct. So it's gonna flip, guys. It's gonna change. It's 1 over 2 square root of 3 over 2. This is 1 over 2 square root of 3 over 2. This is 1 over 2 and this is square root of 3 over 2. I just wrote the coordinates opposite. I'm sorry.
Give me a sec. I gotta erase.
So this is the 1 over 2. First will be 1 over 2, then will be square root of 3 over 2. And similarly for 30, I did wrong in the previous one. So if you want to correct that. So here, this was 45, yes. So it is square root of 3 over 2 and then 1 over 2.
Negative 1, 2.
Let's correct that. So basically, if you want to make a table here now, the final. So this will be our final table here. So this is a unit circle we need to draw. This is a unit circle that you need to draw and you should know how to draw this. This big unit circle. Okay, this I know is 1, 0. I'm just gonna write in degrees. You should know in radians also. 0, 1. This is negative 1, 0. This is 0, negative 1. Okay. Then we said here is 30, 45, 60. So this is our 30 degrees, 45 degrees and 60 degrees. What we next here also we found 3 of them. 1, 2, 3. Here also we found 3. 1, 2, 3. So we found 3 of them. 1, 2, and 3. So 1 over root 3 over 2. Okay. So this is 1 over 2 root 3 over 2. This is square root of 2 over 2 square root of 2 over 2. This thing is square root of 3 over 2 and then 1 over 2. Then we found is 120, 150, and then here we found was, and then 135. 120, 135 and 150. And now just, it's an image, mirror image of these things, and then you just change the signs. For this thing, it will be this thing, but just the values will change. Only my x will become negative, my second will remain the same. This thing is my x will remain negative, and then the second one will remain the same. This becomes negative square root of 3 over 2 and then 1 over 2. For here, what the values we got is, for this we got 225, for 30 we got at 210, and then we got 240. So how you can do is 180 plus 30, 180 plus 45, 180 plus 60. You got these things. Once you got this thing, again, mirror image of these things. Here my x and y both are negative. My x and y both are negative. My x and y both are negative. And from here again, subtract 30, you get 360. Subtract 45, you will get 315, and subtract 60, you get 300. Okay.
And then for each one of those to find radians of it, we just, what is it like?
Radians formula is 180 is equal to pi. So how do you find radians is, so if you have to find 1 radian, right, it is 180 degree divided by pi. So if I have to find, suppose, yes, so you basically are converting into radians. So when you're converting into radians, you have to take it that side. Multiply by pi over 180. Multiply by pi over 180.
Okay.
Your degree, you will get your answer. And this thing becomes square root of 2 over 2, negative square root of 2 over 2, and this thing becomes 1 over 2, negative square root 3 over 2. This thing, if you understand this part here, this whole thing, this is basically your trigonometry. Most of it you covered here. This thing is the main thing. This unit circle, drawing this unit circle is the main thing. And how you find in radians is multiply by pi over 180. Yeah, Jose.
No, I got it. Thanks.
Yeah. Any question, anyone? This is very important. You should know how to draw this.
The homework also had it, I think it was adding, sine and, finding the exact values of 2 additions. Did we cover that, or are you going to go over that?
So let's do an example. Okay, so basically I feel this is, let's see. I guess I did those problems with you. Let's see. So let's say you have to find the value of sine 45 degree, cosine 180 degrees. They want you to find the exact value of this thing. Let's see. I'm going to keep our unit circle here in front of us. I'm going to keep a unit circle. This is our unit circle in front of us. Okay. And Wandai?
Yeah.
What is sine 45?
That is y. So 45.
See, here
it would be root 2 over 2.
Okay, root 2 over 2. What is my cosine 180?
Cosine.
180
Cosine is x, and that's at 180. That's pi? No.
Yeah, cosine is pi, but what's the value?
Value of that.
See here, and this is
That
180.
okay. I see it. That's x. That's -1.
-1. So you get negative square root of 2 over 2. That's your answer. Let's do one more problem here. So if I say you have to find the value of tangent pi over 4 minus sine 3 pi over 2. You're like, tangent pi over 4, what's pi over 4? If you don't know how to convert, you don't know the value in radians, what you do is replace, this pi by 180. That's how you can do it. So you get tangent. Let's convert for pi into 4 into degrees. If you want to convert into degrees, do it into degrees, you can do it. Otherwise, learn to convert into radians itself. How do you do it is, it is opposite, 180 over pi. From radians to degree, you multiply by 180 over pi. And from degree to radians, it is pi over 180. So this cancels, you're left with 45. This is 45. Minus sine 3 pi over 2. Similarly, you can do it. You will get sine 270. And now, see the table here. Let's see here. Daniel.
Yes.
Okay, what's my tan 45?
Okay, so your tangent of 45 is Miss Sec, really quick.
See here, this is T45, right? Okay, I have here this x and this as y. How do I find my tangent?
Tangent, it will be y over x.
And it is the same numbers, right? They are the same numbers.
Yeah.
So when you divide them, what do you get?
So you change sign. So
you get basically square root of 2 over 2 divided by square root of 2 over 2, right? Okay. And then minus, what is sine 270?
Sine of 270 is -1.
Yes, -1. So I put -1. It becomes minus of -1. Let's do the division part here. Square root of 2 over 2. Division changes into multiplication. Then what do you do?
You flip the
Flip.
fraction, so it will be 2 over the square root of 2.
Yes, exactly. And then cancels. When I cancel, what I'm left with here?
I mean 1, I
Yes,
guess.
exactly. Just 1. So you get 1 plus 1, which is 2.
2.
Again, I repeat that unit circle is very important. Once you know this, you can find all the values. Okay, let's do one more example here. So you have here as secant pi by 4 whole square plus cosecant pi by 2. Okay, Gerald.
Hello?
Hello. Yeah. So what is secant pi by 4? What is pi by 4?
Pi over 4 is, let's see. That would be the 45 degrees, correct?
Okay. Yes, exactly. So we are talking about 45 here. This is my 45 here. Okay, this is my x and this is my y. I need to find secant pi over 4. What is secant?
Secant is 1 over x.
1 over x. So I have 1 over square root of 2 over 2, right?
Yes.
So I have 1 over, so many division signs, I'm going to write it like this. Over, I write it like this. Okay. What is pi over 2?
That's 90 degrees.
90 degrees. And what is cosecant 90 degrees?
Cosecant of 90 degrees would be 1 over 1.
Which is just 1, right?
Yes.
Okay. So let's solve this thing. How do I divide this thing? Division changes into multiplication, and then what do you do?
So it would be 1 divided by 2 over square root of 2.
Okay. And then when you change into multiplication, what do you do?
Cross multiply.
No, it flips. It flips.
Yes, so you would get 2 over square root of 2.
Yeah, whole square plus 1. And then you just multiply. For multiplication, you just multiply directly. So you get 2 over square root of 2 whole square plus 1. Which is equal to 4 over 2 plus 1. And this is basically 2 plus 1, which is
3.
Perfect. Any questions, anyone, with this part here? So this was with the unit circle. Mostly you will be doing, most of the problems which you will be doing is with the unit circle. Unit circle is very important. I again repeat, if you will take higher mathematics, make sure you memorize that. Okay, if you memorize today, it will be easier, but later if you try to, see and memorize, it's tough for you to remember. So remember that thing. Okay, so next thing what we're gonna do is, this is not about unit circle. Now my circle can be of any radius. Before I was saying in unit circle my radius was specifically 1. If my radius is specifically 1 here, so now I have here, this is my circle. It can be of any radius r. It can be of any radius. This is my radius. It can be any radius r. Okay. And this is my, remember my center is at origin. Note my center is at origin and then I'm drawing the circle. And my radius is at r. I said this, there is a point xy.
And what coordinate, what degree is that?
Oh, it's any degree. I'm just talking in normal right now.
Oh, okay.
I say it's degree right now. It can be any degree. It can be any degree, but my radius is r. In this case, my radius is not 1. It's r, and there's a point P, x comma y. Okay, now what you have to do it is, in this case, note my sine. In previous case when I had to find my sine theta, I told you it was y. But if it's not a unit circle, it will be y divided by r. The reason in that case it was just y because my r was 1 and y divided by 1 is just 1. That's why it was just y. But in case of general form, it will be y divided by your radius. Similarly, your cosine will be x divided by your radius. It's not just x. Tangent remains the same. Y over x. Cotangent remains the same, x over y. Nikhil, plastic is burning. Can you move a little bit the other side? Okay. Yeah, I can smell the plastic.
Oh, so we're putting it in y over r and x over r because of like using different triangles or something?
No, using different radius of the circle. In previous unit circle, my radius was 1. That's why I was not writing here. Anything divided by 1 is the same thing.
So we're going to be using different unit circles with like different radiuses?
You don't have to memorize. You just have to memorize the unit one. That will help you to find the values. But if in case a different radius is given to you, then you have to use this kind of problem.
Oh, okay.
Yeah, we'll see. We'll be doing problems on this. You'll see. Similarly, your cosecant. Cosecant is basically what it is. You flip the sign. It is r over y. It's not just 1 over y. It is r over y. Note in previous case my r was 1. That's why it was 1 over y. Similarly, secant. Secant theta will be r over x. This is the general form. General form. That we were doing is to draw the unit circle, but this thing is the general form. Also, when your center is at 0, when your center is at 0, there is a formula for the circle. X square plus y square is equal to the radius square. Any point on the circle, you can take the square of those 2 points, you add them, it will be equal to the radius square if your center is at 0, 0. If your center is at 0, 0. This is a formula for circle. Any point on the circle, their coordinate square, and you add them is equal to the radius square. Now, problem on this, how you're going to get it is, example, it says, find the exact value of each of the 6 trigonometric functions of an angle theta if 4 minus 3 is a point on its terminal side in standard position. So you will get a problem like this. So now they are giving you the point. Now they are giving you the point. They are saying a P point is given to you as 4, negative 3. And they want you to find all the trigonometric functions. They want you to find all the trigonometric functions. Note, in this case, it is in standard position. Standard position, general form, standard position. It's not about unit circle. Problems on unit circle, if you get on problems on unit circle, they will say with radius 1, unit circle, or they will be general like 30, 45, 60, 90. We will be talking about general numbers. But in this case, you're talking about 4, negative 3. We don't know what is 4, negative 3. What you're going to do is, for this, you will need something as R. And how do you find is R is using the formula x square plus y square is equal to R square. You're going to use this formula to find your R. So you get R square is equal to 4 square plus negative 3 square. So you get R square is equal to 16 plus 9. You get R.
What's that say right there where it says 4, negative 3 is part on its
terminal side?
Okay, terminal.
Terminal side in standard position. And then you take square root on both sides. You get R is equal to 5. You are like, why I'm not taking the negative number? The reason I'm not taking my negative, because my radius cannot be negative. Radius is always positive. So I got my R. I know my R, I know my X, I know my Y. I can find all the values. Joshua?
Yep.
What's my sine theta?
What?
What's the value of my sine theta?
Oh, negative 3.
Note, my R is different in this case.
Would it be 5? Oh, wait.
Negative 3 divided by, see here, the formula is this now.
Oh, it's negative 3 divided by 5. No.
Yes, it's negative 3 divided by 5. What about my cosine?
It would be 4 divided by 5.
4 divided by 5. What about my tangent?
It would be negative 3 over 5 divided by 4 over 5. Which is negative 20.
Or you can just do directly, see here. It's just y over x. There is no r needed in this.
Oh, yeah.
So what does it become?
Negative 3 over 4.
Perfect. Okay, what about secant, cosecant?
You just reverse, so it'll be 5 over negative 3.
Yes. What about secant?
5 over 4.
Okay, what about cotangent?
4 over negative 3.
Perfect, you got it. Perfect. When your r is different, make sure you divide by your r. You just don't leave it as it is.
Oh. So what's P?
Okay. I'll give you a problem. I want you to do this yourself right now. Okay. Once you've done this, so Nikhil,
Nah.
can you close the windows? Okay. The problem it says is, okay, find the exact value of sine 45 degree plus sine 135 degrees plus sine 225 degrees plus sine 135 degrees. Okay, this is the first problem you'll be doing. Second I want you to do is, so this is your A part. B part will be tangent 60 plus tangent. I want you to start doing these problems yourself right now.
Using the unit circle?
Yeah, these are the unit circle. See, you know why you know is unit circle? Because you know 45, 135, 225, 135. You already know these values using unit circle. So you know you have to use unit circle. Then you have sine 40 plus sine 130 plus sine 220 plus sine 310. Okay, and then your second kind of problem you will be doing is
For the first one, both you have two signs that are 135, right?
yes.
Okay, thank you.
Oh, so it is actually, wait, put 315 degrees. 315.
315?
Yeah, 315.
All right.
Yeah.
I'm a little bit. Do we have to convert them into radians first?
No, you don't have to convert them into radians. Just put the values. Use a unit circle, find the values, and plug in the values here.
So we're using the
Unit
y
circle.
value and then just adding them. Okay.
Exactly, all the y values because it's sine. Yes. Okay, so can I have Josh? What are you doing? Christopher?
Yes.
Okay, Christopher, did you get the value for the first one?
I'm pretty sure it's 0.
Okay, what did you get your sine 45 as?
Sine 45 is root 2 over 2.
Okay, sine 135.
Root 2 over 2.
Okay.
Wait, I got a question now. That's sine 40.
Sine 40, yes, that's sine 40, yes.
Yeah, but isn't it supposed to be sine 45 in order to get the unit circle part?
2 seconds. Sine, yes, it should be sine 45. So, this topic did it not?
And it applies for, and it also applies for all the rest.
It's in the book, it's wrong, yes, it should be 45. They haven't taught you 40 as yet. You will be learning 40, but you don't know as yet, so it's supposed to be 45. You're correct.
Yeah, but also applies for this 130 and 220 and 310, right?
Yes. Don't do this problem because I haven't taught you. Yes, you're correct. This whole thing, don't do this problem.
I was like, wouldn't it be the same problem as A then?
It will be, yes. You don't have to do this. The reason is you haven't learned how to find more angles right now. I'm going to teach in the next session this thing. Yeah. So can I see, yeah. So can you tell me, Christopher, what you got? Square root of 2 plus square root of 2, then plus what is 225?
Negative root 2 over 2.
And 315?
Negative root 2 over 2.
Okay, they cancel, everything cancels, you're left with 0.
Zero.
Correct. Okay. Hugo? Hugo? Not here. Miguel? He's not here. Okay, Angel?
Yeah.
What about the second one?
Tan 60 degrees plus the tan 50.
Okay, what is 60? Tangent of 60.
Tangent of 60 is, 1 second. Is that, what was it again? X over, oh. I forgot what tan was. Was it X over Y or was it?
Y over X.
Y over X, okay. So that'd be Y over X. That's... It's Y, okay, is it, so, 3 pi 2 divided by 1/2? 3 pi 2 divided by 1/2?
Yeah, 3 divided by 1/2. Okay. And what's a 150?
150. I'm not sure. Oh, sorry, I didn't see that. I was looking at mine. That's 1/2 over negative 3 pi halves.
Yeah. If you're saying 1/2 divided by negative this thing. Okay, let's solve. How do you divide?
Well, we flip them and then multiply.
Yes, you flip them and multiply. Similarly, here also I'm gonna flip and multiply. When you do here, they cancel. You're left with square root of 3 plus here when you cancel it, you're left with negative 1 over square root of 3. You're like, I'm supposed to add this. Make a common denominator. So it is basically square root of 3 over 1 or negative 1 over square root of 3. If you know cross multiplication, do cross multiplication. If you don't, make the common denominator. Here is 1, here is square root of 3. I need to make square root of 3 here also. I multiply both with square root of 3. You get 3 over square root of 3 plus negative 1 over square root of 3, which is 2 over square root of 3. But note, I cannot leave a square root in the denominator, so I have to multiply and divide with square root. So you get 2 square root of 3 over 3. You got this thing. Then you have to add. If you know how to make, cross multiply, do the cross multiplication. Otherwise, make the common base. Because here it was square root of 3. I multiply and divide with square root of 3. Square root of 3 times square root of 3. Square root gets cancelled. I'm left with just 3. Here I get square root of 3. Then I can just add the top part here. 3 plus negative 1 is 2. I'm left with square root of 3. But I cannot leave square root in the denominator, so I have to rationalize. And that's what you get your answer. Any questions, anyone so far? Okay. Samantha?
Yes.
Yeah. So next problem we are gonna do is, so in this problem they want you to find all the trigonometric functions and you're just given 1 point, negative 3, 4. You're given a p point, negative 3, 4. I say find all the trigonometric functions using this thing.
So first you use the formula r squared equals x squared plus y squared.
Exactly, yes. And what's my x and y?
Okay, so your x is negative 3.
And then y is?
And your y is 4.
Okay.
And you square that.
Okay. What do you get?
9 plus 16,
Okay. So you get r squared is equal to,
25.
what's your r?
And so your R will be 5.
5. Yes. Perfect. So what's my sine? Sine theta?
Your sine is 4 over 5.
Yes. What about cosine?
Negative 3 over 5.
Okay. Tangent?
Your tangent is 4 over negative 3.
Okay. What about cosecant?
Your secant is negative 3 over 5.
Cosecant is?
Oh, your secant, okay. 5 over 4.
Okay. What about secant?
And your secant is 5 over negative 3.
Okay. What about cotangent?
Negative 3 over 4.
Perfect. Perfect. Very good, Samantha. Okay, Shaira, I know you're asking, okay, since in the previous questions degree was given to you and then you were finding values yourself, you are using the, what do you call, the unit circle. When the angle theta is given to you, you use a unit circle to find the value. But in this case, the point is given to you. The point is given to you. When the point is given to you, you have to find your r and then use the general formula. So another point we did is you have 2, negative 3. Another example we did is p is 2, negative 3. I want you to find all the values for this one. Shaira?
She can't hear you.
Yeah, okay, no problem, Shaira. Okay. Was? Is was here? No. Karen?
Yes.
Okay, Karen. Guess how I'm gonna do this one.
Mm-hmm. So the R is square root of 13.
Okay, let's see. You are saying square root of, you got square root of 3, right? That's what you got?
No, 13.
So, okay, let's see. Let's solve this. So, you get 4 plus 9, right?
Mm-hmm.
And then, yeah, 13. You're correct. So, you get r is equal to square root of 13. Perfect. Okay, what's your sine?
Is 3 square root 13 over 13.
Oh, what is sine?
3 multiply square root of 13
over
13.
Okay. Is it positive or negative, Karen?
Positive.
See, there was negative 3. See here? Why was?
Oh, yeah. Mm-hmm.
So, it's going to be negative. What
Okay.
about cosine?
Cosine is 2 square root of 13 over 13.
Okay. What about tangent?
Tangent is negative 3 over 2. 2.
What about secant?
Secant is square root of 13 over negative 3.
Secant.
2 over 2.
Okay. What about cosecant?
And cosecant. Okay. Cosecant is square root of 13 over negative 3. And
Cotangent.
Cotangent is 2 over -3.
Okay, perfect. Perfect. Any questions, anyone, so far what we did today? If the point is given to you, if a point is given, then make sure you find your R and use a general formula. But if they say, okay, theta is given to you as 45 degree, find all the values, then you're gonna use the unit circle. Then you will use the unit circle. Any questions with today's lecture, guys? Anyone? So with this, I feel, yeah. Someone had question?
Julina said, how did you get -3 square root 13 over 13?
Okay, so
Percent.
okay, let's see here. So basically sine theta will be equal to, if I say the formula is y divided by r, so it becomes -3 divided by square root of 13. But note, you cannot leave square root in the denominator. So what you have to do is, whatever is the square root, you multiply and divide with that same square root, the numerator and the denominator. When you will simplify, you just multiply directly. You get -3 square root of 13 over 2 square roots, the same square roots. When they multiply, they cancel. You are left with just 13. Okay, perfect, Jalina. Anybody else who did not understand this thing? Any questions? Not just this thing. Anybody? Anything in today's lecture?
No, I just had a quick question. So what's your plan for the rest of the week and quiz-wise too?
So, okay, so right now, so this week, okay, tomorrow you have one more lecture, and next week you're going to have your quiz, because tomorrow I want to do one more topic for trigonometry, and that's it for trigonometry, if I finish it tomorrow.
Okay, thank you.
Yeah, if I finish it tomorrow, that's all will be for trigonometry, and because I don't want to do the graphing part. I'm not doing the graphing part for trigonometry. I will be just doing, so technically I'm just doing 6.1, 6.2 and 6.3 for your exam point of view. I'll be doing.
So what's our midterm? Are we gonna have a midterm or?
No, you won't have any midterms, but you will be having quiz. Let me check. You will be having quiz for chapter 6 on Monday, and then we'll start with chapter 7. That's it. Yeah, so pretty much that's it. Yeah, you won't have any. You will have your exam on 15th of October for chapter 6 and chapter 7. Yeah. So let me see, Eduardo here.
Is there a Zoom meeting on Monday?
Yeah.
On Zoom meeting, it depends.
Yeah.
Yeah. Okay, I marked it present. The thing is, Zoom meeting will be there on Monday only if I don't finish tomorrow. Whatever I want to teach tomorrow, if I don't finish, then you'll have a class on Monday. Otherwise, Hugo, Miguel, and Walls. Anybody here? Okay.
I saw Alejandro here.
Andre, yes. So let's see here. Alejandro, yeah, he's here, but he's not speaking. So, okay. Thanks, guys. See you tomorrow. Okay, homework will be assigned, so make sure you do your homework.
You're also uploading your notes right now?
Oh, these notes? Yes, I can upload these notes if you want.
Thank you.
I'll upload my lecture also. I have my video also, so I'll upload that also. Okay.